So we will pick up where we left off. Okay. So we're on the bottom of, I don't know, whatever page it is, somewhere between 1 and 20. Okay. Okay. So what type of function is this particular one? It's a logistic function. Okay. Okay. So is it? So that means it's got what? So it's got what for the graph? In terms of the graph. Sorry, I was not as clear as I wanted to be. It's got two horizontal asymptotes. Okay. Where is the first one? 0 is the first one. Okay. Y equals 0 or x equals 0? Y equals 0. Okay. And where's the second one? Y equals 20. Okay. All right. So we've got that going on. So we've got a y equals 0 and a y equals, oops, got the break, that's a bad, that looks like a G. Oops, that's not even a eraser. There's an eraser. Y equals 20. Okay. All right. What else can we find relatively easily? The y-intercept. How do I find the y-intercept? Plug in 0. Okay, so if I plug in 0, negative 3 times 0 is 0. E to the 0 power is? Which one? 1. Okay. 1 times 2 is? 2 plus 1 is? 3. So my y-intercept then is going to be at 0, comma 20 over 3. Right? Okay. So that would be like a third of the way up. Okay. Is this an exponential growth or an exponential decay? Why decay? No. It's got so it's about the negative 3, right? It's a growth because that's a negative k value. Okay? Remember, logistics are opposite exponential. Okay? So if an exponential is a decay, then the logistic is a growth. Okay? So in this particular case, I'm looking here at 2e to the negative 3x power. I'm looking at that. That's a decay. So the logistic is a growth. So we go through that. If you forget that, what's your option? Plug in another point. Yep. Okay. Plug in some more points for it. Okay. Love it. Good times. All right. Let's switch over here now to logarithmic functions and their graphs, and which should be for you the next page. Okay. Whoa, where did the screen go? There it is. It does it. It does it every day at this time. Okay? All right? You don't have to worry about this part up here because we're doing it right now. Okay? All right? So, solve the following exponential functions without the use of a calculator. 5 to the x equals 25. So what's x? X is 2. Yep. Okay. Because I'll write that out for you, man. 5 to the x power equals 5 squared. So x has to be 2. Okay. What about number 2? Negative 2. Okay. So because this is 3 to the x equals 3 to the negative 2 power. Negative exponents, we flip it over, we move it to the bottom to make it positive. So it's that way. With me? Okay? So then x has to be -2. Next one. -3. Yep. Okay. So 1/2 is to the x power, and 8 is 1/2 to the -3 power. So x would be -3 there. Run out of space. Okay. What about this one? 5 to the x equals 100. Okay. So this one's hard because 5 or 100 is not a power of 5, right? Okay, but we could estimate it, right? What would it be somewhere in between? 2 and 3? Okay, so if I'm thinking about if I'm thinking about 2 and 3 here, 5 squared is 25. 5 cubed is 125. 100 falls in between there. Is 100 closer to 125 or closer to 25? 125. So that means that our answer would be closer to 3 than it would be to 2, right? So I'd probably say somewhere in the neighborhood of 2.75-ish, 2.8-ish, somewhere in that range. Yeah? Anybody? 2.86? Okay. So in order to solve these, what around the year 1594, mathematicians developed logarithms. Okay? And so what we're saying here, and this is something that you should have memorized back in Algebra 2. Okay? So what we're saying here is that if we've got, I'll go and color code it here, log base b of x oops, I put that wrong. Hold on, I just changed my color scheme here. Is equal to y, okay? Then b to the y power is equal to x, color coded. Okay? If and only if x is greater than 0. Okay? The argument, x here, is called the argument. Okay? B is the base, y is the exponent. Logarithms, okay? Logarithms find exponents. They're exponent finders. Okay? Logs are exponent finders. Okay? So when I see log base 3 of 9, I'm asking myself, what exponent do I put on 3 to get 9? What's the answer? 2. Okay? So I put, and that's because 3 squared is equal to 9. They're exponent finders. Okay? Log base 2 of 8, and that's how you say it. log, you say whatever the log, whichever, now we've got logs and we've got natural logs, okay? Right? So log base 2 of 8 is how we read that. Log base 2 of 8. What's that equal to? 3. Log base 5 of 1/25. -2. Log base 8 of 1. 0. Yep. Natural log is log base E. So I don't ever want to see you write down log. Okay? Never write down log base E, okay, or log, is what I call it, because that is natural log. It's got its own separate thing. Okay? So log base E is ln, logarithm natural. Okay? It was a French mathematician, I believe it was René Descartes, that came up with it. Okay? It might out of Euler's number. I'm making this up. Literally as I'm walking around the room. I'm just throwing out French mathematicians left and right. Okay? 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 E I know was developed by Euler, so that's why I know that one. Okay? Right? So this is saying natural log of E is saying what exponent do I have to put on E to get E? 1. 1. E to the 1 is 1. Or excuse me, E to the first power is E. Okay? This is not, one more thing that I wanted to say too. This is not IN. This is not in. Okay? This is a lowercase L N. It's the one and only time you won't see me draw my lowercase L's in cursive. Okay? Right? Because that's not how it goes. Right? What? Look, that's science. They're just riding off of math's coattails, and then they get to do all the fun stuff with math. Yeah, we got to teach you the basics, and they get to do all the fun experiments. Yeah, I said it. I said it out loud.
Yeah, I'm gonna send them the live.
Send them the link. Tell them it's at about the 13-minute mark. Yeah. Yeah. Log base 10. Now, the other special log that's out there is log base 10. Sometimes, I'm not saying every single time, but sometimes if you've got log base 10, I don't know why my G went into my 10 there. If you've got log base 10, sometimes that's just written as log with no base. Because the numerical system that you have is base 10. So that's why we don't ever have to write base 10. So on your calculators, natural log is log base E. On your non-TI calculators, log is log base 10. Okay? On the Inspire calculators, you get to choose what your base is. Okay? So what exponent do I have to put on 10 to get 10,000? 4. Delta 0. Okay? Okay? So that's what we talked about already. We've already done that one. So we can jump down to the basic properties. Okay? Log base B for any base of 1 is always going to be 0, okay? Because b to the 0 power is always 1. So in both of these cases, this would be 0, and this would be 0. Or if you had any base there in that first one, it would still be 0. Log base 78 billion of 1 is still 0. Okay? Log base triangle of 1 is still 0. Okay? Whatever that base is, as long as that is equal to 1, then it's 0. Or if the argument is 1. Log base b of b is equal to 1. So log of 10, or log base 10 of 10, is equal to 1. Natural log of e is equal to 1. We just did that one on the last slide. Log base b of b to the y power is equal to y. Because b to the y power is equal to b, oops, I don't know why I put the equal sign when there's already one there, is equal to b to the y power. Give me an example of log base 10 where that would work. I'll start you out. Log base 10. I'll start you out on the next one too. Natural log. No problem. That's what I'm here for. It's non-science right now. You tell them keep watching through 1731. Log base 10 of 10 to the 10th power? Yeah. Love it. 10 to the 10th power is equal to what? Log base 10 of 10 to the 10th power. 10. Yeah. Who just said they didn't get it? If you've got the same base, then it's just an exponent. So log here is also log base 10 of 10 to the 10th power is 10. Too many 10s for you? Is that what's confusing? Okay, let's change it up here. Actually, no, I don't want to go 100. That's also... I'm going to go 17. It's 17. Okay? Natural log of, give me an e value. E to the 5th is equal to 5. All right. Let's do these without the use of a calculator. You know what? You try it. Then we'll go through it. Yeah. Go for it. All right. There's 6 easy ones and 2 probably confusing ones on there. Give me one of the easy ones. The first one is not -2. It is 1/2. Yep. Okay? Because the square root of 5 is 5 to the 1/2 power. So this is log base 5 of 5 to the 1/2 power. So we just write down the exponent. Okay? Or the answer is the exponent. Be another one. Second one is 2. Log base 10 of 100 is 2. Yes, you are correct there. Give me another one. The third one is 7. Okay? Here's why. If you think about it, you've got 3 log base 3 of 7 equals, I'm just going to say some box, right? Anything. Okay? That's in which form? Is that exponential or is that logarithmic form? That's exponential form. So if I put it into logarithmic form, it would be log, my base is 3, my argument is the box, and my exponent is log base 3 of 7. So if those two are equal, the only thing that can go in the box is 7. Okay? Be another one. We don't have to go in order. 5 is negative 3. I would concur with 5 being negative 3. Give me another one. Number 8 is negative 2. Give me another one. Six is what? 1/3. Yep.
Same thing.
What was? 4 is not 1/7.
Is it 1/8?
Nope.
1/14?
Nope.
1/9?
Nope. Let's just keep throwing out random numbers here. Yep. Let's throw numbers in that aren't even in that problem. That's got to work too. 7 is 5. Yep. So all we got left is 4. 4 is 2 7ths. Yep. Because what's my base? My base is 10. So this would be log base 10 of 100 to the 1/7 power. Yes? 100 is 10 to what power? The second power. So this is log base 10 of 10 squared to the 1/7 power, which is log base 10 of 10 to the 2/7 power. So my exponent then is 2/7. We did. Yep. Okay?
My bad. I apologize.
Where did my graphs go? Oh, nope, they're up there. Okay, that's fine. All right. So log base x of negative 2. Okay? What is x going to be then? 1/100. Yep. Okay. How do we solve? So how do we solve logarithmic function? Say louder. Put it in exponential. How do we solve exponential? Put it in logarithmic function. Those two flippity-flop. Remember when I said log base b of x equals y is b to the y power equals x? Okay? Same thing here. So my base here is 10. My exponent is negative 2. My argument is x. So this one is x equals 1 over 100. Number 2, 16. Switch forms with it. My base is 2, my exponent is 4, my argument is x. Number 3, exact, not rounded. E to the third. Number 4, square root of 10. I was about to say exact, and Punk already beat me to it. Okay? So let's talk graphs of our logarithmic functions. Okay? So first off, I'm going to graph what we already know, which we've already graphed, which was this one right here, an exponential function. Let's just throw one out there just so we have it. Let's go y equals 2 to the x power. Okay? That way we can assign numbers to it. Okay? All right? What is my y-intercept of this function? 1. Okay, so that means my y-intercept is the point 0, 1, which means I go through that point right there. Yes? Okay. Give me another point that it goes through. 1, 2. Okay. All right. Give me another one that it goes through. 2, 4. So it's going to come up through like this, right? Okay. What is the domain of that function? All real numbers? Okay. What is the range of that function? 0 to infinity? Inclusive or exclusive on both? Exclusive? On both? On both? Yep. Okay. Because there's a horizontal asymptote at y equals 0. Okay? Now, exponentials and logarithmics are inverse functions. That's why when we solve an exponential, we put it in logarithmic form. When we solve a logarithmic, we put it in exponential. Okay? Anybody remember how we find inverses? We switch x and y, right? Okay? So my domain of the log function is going to become the range of the exponential function. Because remember, domain is x's, range is y. So my range of my new function is going to be all real numbers. And the domain of my new function is going to be from 0 to infinity, exclusive. instead of having a horizontal asymptote, now I'm going to have a vertical asymptote, and it's going to be where? X equals 0. Instead of having a y-intercept, now I'm going to have an x-intercept, and what's it going to be? 1, 0. Yep. Yeah. So now instead, I'm going to have there. And it's going to go like that. Because if you think about it, so now this would be the function y equals log base 2 of x. Okay? So points that this one is going to go through, so I should put these points over back here. So over here, this went through 0, 1, 1, 2, 2, 4, and 3, 8. Over here, because we switched the x and the y, it's going to go through 1, 0, 2, 1, 4, 2, and 8, 3. Because we flippity-flop the x's and the y's. Yep. Now, typically, when we are graphing logarithmic functions, okay, typically what we do is we ask you to find us 2 special points. Okay? And that's going to be the 2 easy ones. In an exponential, it's usually what makes the exponent 0 and the exponent 1. Okay? Which here in a logarithmic function, it's going to make the y value be 0 and the y value be 1. So I want to find when this is going to be 0 and when this is going to be 1. So if I think about it, what's going to make this be 0? Ten's going to make it be not 0. What's going to make it be 0? 1. Okay? So if this is 1 here, then this is really log base 10 of 1, which was one of our special properties 2 pages ago, that's always 0. Right? Okay? What's going to make this be 1? 10, right? If I fill that box with 10, my logarithmic, or my exponent then is 1. Okay? So on your graph, now I get it that when we're dealing with asymptotes that are on the axes, that you might have to, like some people do this instead, and I'm totally fine with that. Instead of doing a dashed line, some people kind of do like slashes all the way down, but you can actually see the asymptote on an axis. That's great. Okay, that's more information, and then it's going to come up through here, come out through here, and then we can add in our 2 points. So this is the point 1, 0, and over here would be the point 10, 1, somewhere on down the line. y equals the natural log of x. I want a 0 and I want a 1. So what's going to make it be, what's going to make y be 0? One. If I plug in 1, natural log of 1, is that 0? No. Because if that argument is 1, that logarithm is 0. Okay. What's going to make it be 1? E is going to make it be 1. Now, do we remember what E is? 2.789 or 2.78182828, something like that. And there's a 2828 somewhere in it. I'm not just having direct over here. Okay? All right? Okay? What? What do you got? You thought I was just up here just randomly spouting out stuff again, making stuff up. Nope. Actually doing it. Doing it on the real. So there's our vertical asymptote. Our function is going to come in through here. Come in through there. And then here now we're going to go through the point 1, 0. And we're going to go through the point E, 1. And we can just write it like that because that's our wonderfulness that is that. Yeah. Huh? Let's get into some properties of logs so that tomorrow we can be solving logarithmic equations. Okay? So the first rule, and again, I'm going through these quickly because you did these last year in Algebra 2. Okay, right? This is literal, just refreshing from last year. Okay? Product rule of this says that then the log base b of u plus log base b of v. Okay? So multiplication goes with addition. Expansion is going to the right on these properties. Condensing is going to the left on these properties. Okay? So if we say to expand one, we're expecting it to be many logs in your final answer. If we are condensing, we expect it to be 1 log in your answer. Okay? You're cooking bacon back there? Frying it up in a pan? All right? Cook for me the quotient rule then. Let's say it right though. Log B. Remember how I told you how to say this? We spent like a minute on refreshing. Yep, exactly. Log base B of u. Yep, exactly. Okay. I would hope that you don't go to French class and start talking German. You know what I mean? I gotta teach you how to say it right. Okay? Right? So division goes with subtraction. Okay? What about the power rule? C times log base B of u. If you're using a TI Inspire calculator, you don't need to change your base, but if you're using a regular, like the TI 30 II axis or some of the other just regular scientific calculators, you do. Does anybody remember what the change of base formula is? Log of u divided by log of b, or natural log of u divided by natural log of b. Nope. You're going to get the same answer. Okay? And that's if we needed to solve. So like before, we had log base 5 of 100, and we didn't know what it was. If we didn't have our inspires, we would have to use this. We would do log of 100 divided by log of 5, or natural log of 100 divided by natural log of 5. Okay? All right? So let's expand and condense. Okay? So if I am expanding this one, the first thing that I'm going to do is I'm going to say, okay, all of these are being multiplied together. So that means that I've got log of 100 plus log of x plus log of y to the 5th. So I broke it up into its 3 parts. Right? Okay? Log of 100. Do I like that? What do I like instead? 2. I just like 2 there instead. Okay? Log of x. Do I like that one? Yep, I like that one. Log of y to the 5th. Do I like that one? What do I like instead? 5 log of y. Yep. And that's it. Like before I did the blue step, because the exponent is only on the y. In number 2, we'll do a quotient 1, 2 right away. In number 2, I like the natural log of x squared minus the natural log of y cubed. Do I like the natural log of x squared? What do I like in its stead? 2 natural log of x. Do I like natural log of y cubed? Nope. What do I like instead? 3 natural logs of y. Okay? You try the other 2. Should get here 1/3 log of x plus 2 log of y minus 1 minus log of z. Questions, comments, concerns, clarification? Go ahead and ask.
What is that? Would be the -1, the -1.
Nope. Because you're dividing by z. Right? Z's in the bottom, right?
Yeah, but
Okay. All right. So let me go back up one step. So this would be log of the cube root of x, right? Plus log of y squared, right? Good so far? Okay. Then it's minus this, right?
oh, so you just
Right? Which this then is right? But that's still inside that parentheses This negative has to go there. That's why that one's minus. This negative has to go there. That's why that one's minus. Okay. Number 4 should have been 1/2 natural log of x. Oops. Didn't pick up the pen far enough. 1/2 natural log of x plus 4 minus 5 natural log of z. Parentheses important there on the x plus 4. Extremely important, because otherwise it's a totally different problem. Okay. Good? All right. Let's condense now. Let's go the other way. Okay? So in here, what I'm thinking is this would become log of x to the 1/2 power minus log of y cubed I'm going to have log x to the 1/2 power is the square root of x. Because it's subtraction, it's division, and then it's y cubed on the bottom. We know that this one is going to be natural log, yes? Okay. Is it going to have a fraction? Yes, because there's some subtraction. Okay. Tell me what goes on top. 2. What goes on the bottom? X, y cubed. Because they're both being subtracted, they're both on the bottom. No, because it's not log, it's natural log. Okay? Good spot to end for today.